Thank you. This panel, The Future of Vehicles, will be moderated by Professor John Heywood. Professor Heywood is Sanjay Professor of Mechanical Engineering and Director of the Sloan Automotive Laboratory here at MIT. I will give no further introduction and just turn it over to Professor Heywood. Thank you.
Well, welcome to this panel. And as the title says, it says the future of vehicles. You could even flip that around and say vehicles of the future. Whichever one you use, that's a very big topic. And so I'm just going to use a few minutes by way of introduction to perhaps focus our thoughts so that we make steady progress through this session and come out feeling, yes, we've learned something. If you go back to the title of this conference, you'll see that it says solutions that scale to meet the energy challenge. I'll come back to that word scale in just a minute. As we were planning this session, we had a subtitle, and it was really changing the game for vehicles. And I think that's a good place to define our scope, changing the game for vehicles. And now let's bring in at scale. And it's interesting, we're using that phrase, at scale, in the energy business. If you look at a dictionary under scale, there's about 6 column inches that define many meanings for scale. And there isn't one that obviously fits what we mean by at scale. What we mean is very large scale. Many of my students are here. They tell you when I edit their writings, I always cross out 9 of the 10 veries that they write in their text. Very doesn't add very much. So I'm going to say very, very large scale, because that's what it is in all of these energy sectors. And it's especially important in the transportation sector, where vehicle technologies and fuels are remarkably homogeneous. So what are the questions here? Well, I think there's 2, and it's changing the game. How are we progressing? How are we doing? Are we making progress? Are we yet having any impact? So that's, I think, one type of question that I hope will come out in the presentations and the discussion. And then let's go on from that when we see how well or not so well we're doing in the nearer term. What opportunities, how big a change could we ultimately make? Because as you know, we're all starting to talk about in 2050, can we reduce greenhouse gas emissions by 50 to 80%? And most of us don't have any idea how challenging a task that is. And I haven't even defined what the baseline is, but it doesn't matter. It's an incredible challenge anyway, whatever baseline we choose to make, because growth is taking us in the opposite direction. So we will need lots of actions, and all the major stakeholders are going to need to be involved in this and play a critical roles. And we've got 3 representatives from the different stakeholders involved in this as our panelists today. We've got Christopher Grundler, who's Deputy Director of the EPA Office of Transportation and Air Quality. We've got Edward Cohen, who's Vice President, Government and Industry Relations at American Honda Motor Company, and we've got JAN-OLAF WILLUMS, who's President and CEO of the Think Global AS. And so we've got somebody from the regulatory community, we've got somebody from the industry, and we've got somebody from the entrepreneurial community. And they're going to speak in turn in that order, and we'll hold questions until all our panelists have had a chance to make their points, and then we'll have some questions amongst the panelists, and then we'll open it up to you, and I hope we'll have a lively session. So Chris, please, would you get us started?
Thank you, Professor. I'm delighted to be here, and let me first say what an honor it is to be on the same podium as Professor Heywood. Professor Heywood has many admirers at my agency, and it's a very privileged to be here. I also have a warm spot for this institution because one of our young, smart, recent hires was just awarded his PhD from MIT and his master's in the Technology and Policy program, and he's making a big difference already at EPA. And so I'm also recruiting. We're hiring, and if any of the students are public service minded, come see me after this panel session. Well, since I'm first up, I thought I'd try to set the context here. It's a very dynamic time, as I'm sure most of you know, with respect to climate policy, and the regulatory landscape in particular has changed dramatically over the last year or so. So allow me to recap a bit what 2007 was like in my world. It started with the president, of course, admitting to the world that America is addicted to oil. No surprise there. But he also put forth a legislative proposal that targeted displacing 20% of gasoline use in America by 2017, and that's a pretty big number. Then in April, in a pretty stunning decision to most of us, the Supreme Court decided that greenhouse gas emissions should be considered a pollutant in the meaning of the Clean Air Act, and directed EPA, should the administrator find that greenhouse gas emissions contribute to or cause public welfare endangerment, that we're obligated to regulate greenhouse gas emissions from mobile sources. And then what really rocked my world, about 6 weeks after that, President Bush issued an executive order telling EPA to work with other federal agencies and get busy and produce not only a vehicle greenhouse gas rule, but also a fuels rule by the end of December. So that changed things at EPA in quite a hurry. And then in the meantime, no strategy succeeding like success, we got 7 more petitions from various states and environmental communities asking EPA to set greenhouse gas regulations for other categories of transportation, including off-road machines, aircraft, and marine. So it was a very eventful year. We did meet our deadline, but a funny thing happened on the way to the Federal Register. Who knew that Congress and the President would agree on a new energy law, which increased CAFE standards by 40%. And also set new mandates for substantial volume of renewable fuels. In fact, 5 times, we had just finalized our first renewable fuel standard in September, and by December, Congress has told us to increase it by 5 times. So it's been a very eventful year at EPA. And I want to just briefly describe the substantial body of technical and analytical work that was accomplished in a very short period of time while we were working with our colleagues at DOE and DOT over the last half of 2007 to produce these performance standards. In fact, we worked with the DOT Volpe Center right across the street from us here with respect to developing detailed technical and cost analysis for a variety of emission reductions scenarios. We used the latest information from the literature. We looked at the work that California had done to do their proposed CO2 standards. We looked at EPA's certification and fuel economy database, a very robust set of data on all the latest vehicles. So we looked at scores of technologies, assembled them in a variety of different technology packages, and all of this formed inputs to Department of Transportation's CAFE model. And it produced some very remarkable results. But in addition to using this, what I'd call best engineering judgment and looking at all the latest information about what technology can do, we also commissioned a study with Ricardo, leading an automotive engineering firm, for an independent check. And we had 3 specific goals. One, we wanted to have a peer-reviewed source document of various different technology effectiveness of different automotive technologies. And we wanted to also understand and quantify the synergistic impacts of assembling different vehicle technologies on different types of platforms. And they have a proprietary full vehicle simulation model, which, by the way, automakers hire them to do this, to come up with an understanding of what a full vehicle would do. And lastly, of course, we wanted to quantify what different individual vehicle technologies and combinations of technology could produce in terms of reduced emissions. And the bottom line of this report is that, as you might expect, there are many different technology opportunities in the near term to reduce CO2 emissions from vehicles by 30%, or the equivalent fuel economy improvement of 35 to 40%. And this was a very conservative analysis, because the baseline included recent improvements. We held weight and performance constant. We didn't consider air conditioning improvements, and we didn't consider battery electric vehicles or plug-in hybrid electric vehicles, and very low hybrid electric penetration. And we also used the AEO 2008 fuel price projections for 2017, which I think were about $48 a barrel. So despite this constrained analysis and conservative assumption, we found that fuel economy improvement of 35 to 40% and greenhouse gas emission reductions of 25 to 30% were very doable. So the current state, post-energy law enactment, EPA's had a period of introspection to try to understand how the new energy bill affects our response to the Supreme Court, how to handle all these different petitions. And the administrator recently decided to, in my world, what's called an advance notice of proposed rulemaking, to issue an advance notice of proposed rulemaking this spring, which will lay out EPA's thinking on how to use the Clean Air Act to regulate greenhouse gases from all sources, not just transportation sources, but utilities and industry as well, because what we discovered over the past years by regulating one aspect under the Clean Air Act has important implications for other sources. With respect to transport, it will allow us to get all this information out to the analytical community to comment on, as well as to look at an integrated systems approach, looking at technologies and fuels, as well as behavior in terms of how what's the smartest way to reduce emissions from this sector. So I expect this process is going to be very useful to Congress as it continues its deliberations of what our national strategy should be. So in closing, I think we heard this morning from John Doerr's daughters that they will judge us pretty harshly in terms of how we address this challenge. And to me, I think the question is, are we going to follow the same kind of incremental compliance-based approach, looking at 3 or 5 year increments, or using Doerr's words, are we going to follow more of a long-term need-based approach where it's going to be much more of a disruptive, revolutionary technology approach? And I think science is telling us that the planet needs the latter approach. And the challenge is going to be getting the right policy and market signals in place so that we move these kinds of technologies to the market in numbers that matter. Scale and timing matter. Thanks for listening.
Thanks. And so Ed Cohen from American Honda Motor Company is up next. Please.
Thank you. Actually, I learned something today, Professor. 35 years ago, I had a law school professor who also struck the word very in every place I wrote it, and it turns out this is an international conspiracy to do in the word very. So, interesting. One of the challenges that we were asked to address today is what are the implications of the CAFE rule? And for those of you that don't know the vernacular, CAFE is short for fuel economy. And let me just tell you right now, this law that Congress passed, A, was unanticipated in its scope, and B, is a fundamental game changer. It's a game changer in many respects, but for a company like ours, whose marketplace niche always was superior fuel economy relative to the competition, everybody else needs to now come up to where we are, and we have to continue to go beyond where we are. So it's a fundamental game changer in terms of competition. It will also be a game changer in terms of technology, as I'll talk about in a moment. Secondly, if you take a look at page 23 of the brochure, there's a very important chart there that talks about a major change in the structure of the fuel economy law, and that is that each manufacturer now is going to have its own standard based upon the attributes of its vehicles. Most likely it will be size-based, so that means a company like Honda will actually have to attain 38, 39 miles per gallon, where another company that makes a large number of larger, perhaps heavier vehicles, may be in the 34, 33 range. So there are very significant changes coming. When companies like ours look to how we're going to meet this in the future, there really are two major factors that we look at that are entirely outside our control. The first are our customers. If the rap about CAFE is that it's supply side only, it's true. We cannot make people buy vehicles. So the successful company is going to be the one that can achieve the standards at a minimum, but also achieve the performance and safety and environmental expectations of its customers. And in that regard, say what you will about higher gasoline prices, but it certainly is going to help companies comply because it will provide a real marketplace motivation for customers to look for more fuel-efficient, perhaps smaller vehicles, which, of course, certainly the fuel-efficient side is what we're going to need in order to sell vehicles. With that kind of a brief overview, the second factor that's outside of our control are the regulators, among them Chris. And the reason I say this is that a lot of what we do, we are told to do. A company like ours does not oppose government regulation. We understand the need for it. In fact, we understand that government can serve as a good motivator, if you will, of technology. But at the moment, we're facing 35 mile per gallon minimum CAFE standards by 2020, and I remind you that's the minimum. It can be higher, and the rest of the statute says that by 2030, it's the maximum feasible. So 35 is an interim stop along the way. And secondly, greenhouse gas regulation, in my judgment, is inevitable. At the moment, we have nothing but total chaos out there about who's going to do it, whether it's going to be Chris or whether it's going to be the state of California or whether it's going to be the state of California in 16 states. And whatever it is, I believe that the greenhouse gas obligations on motor vehicle manufacturers are going to make the CAFE standards look small, not large. So when we're thinking about this, we're immediately thinking about 35 miles per gallon, but I think we have to be mindful of two things. One is, does California ultimately get the right to regulate greenhouse gas? And if they do, then we already know 35 is low. And secondly, that the standard is only 35 as an interim stop. So what are we going to do about this? The major point that I want to make for you entrepreneurs is there is no single technology that's going to get us where we need to go. This is going to be a function of many different technologies working to meet particular needs of users. The internal combustion engine, gasoline, is here for a long time. If you hold gasoline stock, don't sell it. We are going to be working to refine the internal combustion gasoline engine. It's a very inefficient use of energy right now, and there's a lot of efficiency that can be pulled out of the internal combustion engine. We're going to be lightweighting, which means we're going to try to make our vehicles lighter, try to maintain the size. We think you can do that. If you have a question what this means, our 2009 pilot has 52% high-strength, lightweight steel. The current pilot, which will be phased out in the next couple months, was 13%. So fundamental materials changes. We're going to be bringing a diesel to the U.S. In 2009, 2010. I think there's some issues out there that need to be addressed, including, first of all, will customers accept it? And secondly, what's going to happen to the price of diesel? Right now, it's significantly higher than gasoline. Part of the reason for that is 50% of the fleet in Europe is diesel. And while we weren't using very much diesel for passenger cars, they were content to keep the diesel and send us the gasoline. If we now start putting pressure for diesel, which gets 30% higher fuel economy than gasoline, then you can see that we're headed for significant increases in prices there. There is electric drive in everybody's future. So if you make electric motors, if you make batteries, Godspeed, especially on the battery side. Honda was the first to bring a hybrid to the U.S. The Insight, we have the Civic Hybrid now. In 2009, we're bringing a new dedicated hybrid. The vehicle will sport only a hybrid motor. It will be smaller than the Civic, but the point about this vehicle is that we're going to try and cut in half the price differential between gasoline electric hybrid and an internal combustion gasoline engine. PHEVs, so-called plug-in hybrid electric vehicles, great in concept. Everybody's working on them. We're working on them. Some terrific technology came out of MIT with A123. Until it is shown that these are economically viable for customers, they're a great idea and nothing more. But battery technology has made a lot of progress, but we are not there yet. And then finally, what we think is the granddaddy of the technologies is fuel cell vehicles and hydrogen. Honda has announced that starting in June, we'll be leasing in California for $600 a month, including, by the way, insurance and maintenance. Our Clarity fuel cell vehicle, it is a very cool looking car. It's almost worth moving to California to be able to be eligible for one. The major issue and the major challenge, and I hope people ask questions more about the role of government because I got a lot to say about this. One of our major concerns is where's the infrastructure coming from? The Department of Energy, which was very excited about hydrogen, somehow is reduced its budget considerably on research on developing hydrogen. This is a serious problem for those of you that work on the Hill because fuel cell technology may not be the technology for 2 years from now. It is the technology for the future. And if we don't start now addressing some of the basic issues of where is the hydrogen going to come from, we're going to get way behind this game. This is a terrific opportunity for us. One last point I want to make, because I've got the time sign kind of going in front of me, is this. Associated with a lot of these technologies are infrastructure issues, as I've mentioned, with respect to the clarity. One of the things that our company is doing is looking at that and looking at the concept of distributed power. We produce the only natural gas passenger car sold in the U.S., and we are now also marketing a home refueling device that basically allows you to fuel your vehicle overnight in your garage. The benefit of that is that it brings natural gas to the customer. More importantly, we're doing the same thing with hydrogen. We're developing a home energy station that reformulates natural gas into hydrogen as well as heat and electricity for the home. So I certainly see home refueling as a transition to infrastructure, but as we're talking about these vehicles, we also need to be talking about the infrastructure. Thank you.
Well, thank you, Ed. And next is our final panelist, JAN-OLAF WILLUMS, who's with Think Global.
Thank you very much. And obviously also I have to say I'm so happy to be here because I took my PhD here 33 years ago. That time it was about how to find oil and gas in China. I was one of the first who was allowed to get into China. And I've been in China and tell them, how can you avoid using that oil and gas for driving cars? And it's a quite interesting development. John Doerr said something this morning which hit me very much, and that is what we saw in China, the growth of the cities. The real growth of the pollution is in the cities. So we said several years ago, we need to develop a car for the city. I know that cars, we were told at that time, cars should be 5-seater, having space for your luggage, your dog, and your golf equipment, and it should drive 400 miles without having to stop. And I think that's a perfect car for the Midwest and from the US. And we said to our friends, I'm sure you have such a car. If you're from MIT, you have a Volvo. I have a Volvo at home because I'm from MIT. But 95% of your time, you really don't use it. We have statistics because we have produced now over 1,000 cars. They've been running several years in Scandinavia. 95% of the time when people have an electric car and another car, they use the electric car. It's more convenience, it's easier to drive, easier to go into the city. Why do you need 2 tons of steel to go to get out your milk or to deliver your children to school? So we see a pattern changing very rapidly, that people become city people, they need something else. Either they need a car to go only that, or they have maybe 2 cars, or they can borrow a car, or they can make car leasing. There are many models. So our point is we have to rethink the whole mobility concept. And when we took over this car, which was originally actually a Ford company many years ago, we said, let's rethink what you really need as a transport. And we were lucky enough, that we were invited by Google to go and spend a day 1.5 years ago brainstorming a Googleplex of what do you really need? What is really the need for you have, and what are the risks? And we found quickly out electric cars, that's dangerous. It has something called battery. It might last for half a year and cost a fortune. So we said, fine, we'll take the battery. We'll just guarantee that in your car you have enough energy for 150, 180 kilometers, no case, 100 miles, and a way afterwards to charge it as rapidly as possible. And if it doesn't work, fine, we'll change the car. So we took out the risk of the electric car aspect to it. At the same time, we said, maybe we could do other things. If you have this monthly relation with you, we could actually build a very good relation. So we put insurance in, we put the carbon offsets in, we know how much electricity you get per month from each place, and we control all that and we compensate for that. We also said, given that we own the battery, we'd like to optimize the life of the battery. The longer it lasts, the better it is for us. So we can afford the very expensive batteries. That's why we have A123 batteries. They're good, but they're a bit expensive. So from that point of view, we want to have batteries which last quite well, because that becomes another economic incentive instead of just saying, sell it and forget the customer. Now, all those things sounds great, and I took this picture up here not only to have a little color into the future of the vehicle 2020 and beyond, because this is not beyond. This is today. Those two cars are being produced now. We have already 1,200 cars of the earlier model. This car was launched at the Geneva Auto Salon, and we have already sold to France, to Switzerland, to the Prince of Monaco. He opened the Monte Carlo marathon with a blue think, just to make a point that I'm thinking clean. So this is not the future. It's not the future. It is today here. What can we do as a small company? The one in the middle is a concept car, which is our next generation car developed together with Porsche, and is a really nice car for the people who need more than a 2 or a 2+2 seater. Now, back to your question, what incentives do we need? Why did that happen in Norway? We don't have a coffee stand, we're even not a car-producing nation. In a way we are, because Sweden is next to us and our factory is 20 kilometers away from the border. And 100 years ago we were kind of one union, but for us there is a very interesting area where we have a tradition not only for cars but for electricity, for clean electricity, hydropower mostly, and for environment. So for us it was very logical to try to find interesting models to create a new car. And I think we've managed it. We have a long waiting list in Scandinavia, and we have now deals in other countries because there are interesting incentives. Sarkozy, when he became president, first thing he announced was a bonus-malus system. If you have a Hummer, you pay about 5,000, 6,000 euros extra fee when you buy it. If you have a Think, you get 5,000 euros. So it's a very nice balancing. So for us, suddenly, the electric car in France is a very good deal. In other countries, they combine it. In Monaco has 30% rebate on the price of the car from the government. Denmark is starting to make it tax-free. Norway, we pay no TVA, nothing at all. And there are non-economic incentives, like we can drive in the bus lane. I know California is driving in, you're allowed the Priuses even, which is maybe not so environmentally friendly as they think, to drive in the diamond lane or whatever you call it. We think that having 2 people is maybe an over-exaggeration that you say it's a very full car. That's a little bit more normal in Norway. But basically, there are non-economic incentives which makes it very interesting. The whole point is we have to think out of the box. The idea with the car sharing, with the battery, all those is that we have to think slightly different, slightly new. A small company can do that. We are a small company. I think we're 250 today. We were 240 last week. We're growing, but we have an opportunity to make alliances. We made a great deal with General Electric, they're our partner, because they thought interesting ideas, let's support them, let's invest, and let's really develop new technology. We raised, within 6 weeks, we raised $93 million last year, because people liked the idea, liked the concept. We have other partners. Our car is produced with parts by Ford, by Peugeot and others. We put them together. We are not a car producer. We are a car assembler, and we are a rethinker of what the needs are from the public. And I think that is what really the big companies need. And where we have excellent communications with the big Germans, the big American car companies, they like to see what we're doing. They think maybe there are ideas they can take over. And there, I think, even as a small company, we have a very important role to really be the initiator, to be the people who are allowed to test new ideas, who can kind of continue the MIT spirit of entrepreneurship. And then the big guys will probably learn sooner or later, and we'll have a good time in between. So in summary, there are new alliances built up. For us, For in the old days, it was the car company and the oil company. In the new days, it's the electric car company and the utilities. We have very interesting alliances with E.ON in Germany, with EDF in France. They see very interesting synergies, and we look at the synergies. Technology can develop out of that. That can be peak shaving and many other interesting things. Dong, the biggest energy company in Denmark, said, we like to work with you because you will help us allow that we can use electricity at night, and we have too much at night, we have too little in the morning. You can be a buffer. You have many interesting ideas. So in conclusion, there are many opportunities for small companies like us to be creative, to be successful, to make money, and try to change the game so that the big guys can afterwards get the scaling which you're looking for. Thank you.
Well, let me get our panelists to interact for just a minute before we open this up. And I've got a question that's got two parts that I hope will do that. The first is that, as you've heard, in 2020, last fall, Congress passed the energy bill, which has got this 35 miles per gallon corporate average fuel economy requirement. That's a 40% increase in fuel economy from today, and it applies to all vehicles in some sense that they've all got to improve by about 40%, some more, some less, but that's the task. So let me ask our panel, what do they think, in broad brush terms, it will take to achieve that? 2020 is 10 years away. All right, 12, but, you know, we got to get ready. So it's 10 years in real world time, and, as I said, all the sales mix has got to improve by that 40%. Now, Chris was fairly optimistic. I think Ed was more cautious. Let me ask you, broad brush, what do you think it's going to take to achieve that? Not 35% diesels, but less detailed. And then what are the consumers going to feel as you all work very hard to get there?
Well, I'll start by just reiterating what I said in my opening comments. Our analysis, and hopefully it will be available for MIT and others to critique pretty soon. But both our work with the Department of Transportation, that's confirmed by our work with Ricardo, which we've now shared with the National Academy, who's updating their 2002 report, suggests that 2020 target can be achieved largely through improvements in today's gasoline technology. Our projections show that improvements to transmissions, valve trains, downsizing engines with turbocharging and so on can achieve those levels cost effectively, even with conservative economic assumptions. So I don't see it as much of that target as much of a game changer as my friend Ed does. In fact, what I think needs to happen in Congress is obviously going to figure this out to get the real long-term signal in terms of what the atmosphere needs. Is we're going to need a very different set of both policy and market signals to try to send the right signal so people will want to buy Jan's vehicles. But then, and we don't have that yet. So I think 2020, in fact, Ed's competitors, no doubt to Honda's chagrin, has already announced, one of his competitors, that they're going to beat that 2020 target both in time and in fuel economy levels. So as to the consumer, there's a lot of evidence suggesting that American consumers' tastes are beginning to change, and that there's going to be a growing demand for lower emitting fuel efficient vehicles, particularly if other attributes are held pretty constant. And again, in terms of our conservative analysis, we assume the same kind of mix we see today, the same 0 to 60 performance today, the same sizes today, and results are what I described to you. So if you can imagine the kind of innovation that Ed talked about in terms of weight substitution, in terms of greater progress with batteries, I think much more can be done, and I think there will be a demand to it, particularly if oil prices stay where they are or grow. Now, of course, it all goes out the window if oil goes back to $30 or $40 a barrel, and that's unpredictable.
Ed, you want to respond?
Well, first of all, in respect to our competitor who said that they're going to be 35 before 2020, well, they're going to have to, because of the mix of their vehicles. They're going to have to be at 35 by around 2018, and frankly, we'll be 35 by 2020 also, because we have to, for the reason that I mentioned before. So don't get too excited about that pledge. Secondly, I want to make the point that 12 years is not a very long time, believe it or not, certainly not in major model change cycles for motor vehicles. Typically, they're in 5-year increments, maybe 4, maybe 6. But when I can remember when we were sort of lobbying, God forbid, this bill up on the Hill, you know, manufacturers would try to seek an additional year, additional 2 years, and you could actually step back and figure out why, because you could see their big volume cars were on a certain cycle for major model changes, and another year gave them another cycle. So 12 years is not very long, and for that reason, I don't see radical changes in the technology per se. The reason I said this was a major game changer is, first of all, it sets us on a course that I think will go beyond 2020, and secondly, it does change the competitive landscape. How we're going to do it, keep in mind that as big as and as exciting as hybrid vehicles are, they're only 2.5% of sales this year. The projection is maybe 10% by 2015. And that's probably the technology that I think will make the most progress sales-wise the fastest. I agree with Chris that a lot of the change is going to come from the internal combustion engine and other things that you do to vehicles. For example, we have a variable cylinder management in our 6-cylinder vehicles. Operates on a 3, 4, 6-cylinder load depending upon what the engine load is, and that gets us a few percent, 6, 7, 8, 9%. There's no magic bullet here. To get this kind of change in this relatively short period of time, it's going to take refinement of virtually every component of the vehicle. And so it's going to be incremental. And so with that, I'll pass it on.
And maybe, Jan, you could say, since you're looking at new technology, how much of that would be relevant before 2020, or is it going to take longer to have an impact? Maybe you can address the question that way, please.
I think that the large cars will have this incremental improvement, but I think it will be faster because there are much more going on making equipment lighter, making elements lighter. I believe much more in the serial hybrid for the large cars, which means that you start with looking at the electric engine as the driving entity, although obviously one is used for 103 years to develop and optimize the other engine, the internal combustion. I think the electric engine will have a very strong future, and much development will happen there. I even was told that Ferdinand Porsche, the first car he designed, was an electric car. And then obviously the infrastructure was maybe not there, but the infrastructure is very good for the oil and gas. But I think the large car will have a development towards a serial hybrid so that you can have this range for the people living in Arkansas, or people have to go from Boston to Cape Cod and whatever they want to go. But I think that the second market will grow much faster, much quicker, the small car market, the city car market. And suddenly you will see a shift in the mix, that you have two types of commute, one the local one and one the big one. And I think that balance between those two will shift much quicker than you expect. We see it in Europe, the growth of smaller cars, the Mini, the Cinquecento, the new Fiat, incredible successes. People like those small cars. Another interesting aspect that I was told by the car journalist for Time magazine, he said, I just interviewed people in Japan. The status report of a car has disappeared with young people. They are interested in mobility, not in having a fancy car with a fancy label. So the number of horsepower, the number of cubic at the back is a thing of the past. So I think this idea, mobility and easy mobility will be more and more important. There will be a development of the other car also, of the car for the people who need the long term, and that will be more and more serial hybrid.
Good, thank you. Well, let's open it up to the audience and see what questions you have for the panel. Please, sir, on this table here.
Forgive me for this, but it's much too tempting. It's not a question, but I'd like to make a contribution.
No, please. We haven't got much time, so please make a question with you.
A question? Okay. I have an invention that, are you interested in going, if you're interested in a 100-mile per gallon vehicle, you have to get the mass down. Small car is nice in the city. If you're on the highway, you need collision protection. I have an invention that has a bumper zone, but it's not a question zone. I'm sorry.
A little comment on that. These small cars have a 5-star rating, just 4-star rating, sorry. It's not that bad.
Okay, let's try over there, please, against the wall. Sir.
Hello? Lawrence Walmsley from McKinsey. I want to ask you about the interaction between the various sectors of society. Given how critical energy is for our society today, fundamental change is only going to happen if technology, business, and government actually come together and work together. So I want to ask you how you see that playing out in the vehicle field, if those three groups will be able to coordinate, and in what particular areas do you see that happening?
I'll start. I completely agree with you, and I think climate change is such a profoundly different problem that for EPA that we frankly haven't addressed in the multiple dimensions. I think the Europeans have a term for dealing with such complicated problems in terms of all the different elements of policy that have to be addressed. And in this case, I think narrow technical solutions are not going to suffice. And with respect to transportation, it's this system with respect to the fuel and with respect to the technology and with respect to behavior that all have to come into play. I mean, I agree with almost everything that Ed Cohen said in his remarks. There are customers out there, and they have a certain demand. And until that demand scenario changes in terms of what we need, what we think we need, and how we use that, we're not going to be able to solve this problem. So we have to address land use issues, we have to address vehicle mile traveled issue along with these technology approaches, because VMT continues to rise 2 and sometimes over 2% per year, vehicle mile traveled in this country. I think it's growing in Europe as well. Freight vehicle miles traveled are growing at an even faster rate global because of the global economy. Shipping rates are increasing, and so you're fighting against this growth in activity with technology. And so with respect to shipping, we have to come up with more efficient operations. With respect to freight movement, goods movement across the globe, looking at these intermodal contributions. With respect to consumers, what are they buying, how are they using these vehicles, where are they choosing to live, and that brings in all these other social aspects. And that's why this is such a profoundly different problem than, for example, just reducing NOx from vehicles. And so it's going to require this type of interaction, and it's going to require both business leaders and government leaders and humans to sort this out. And it's going to be hard, but it's essential.
I'd like to address a slightly different aspect of that question. It was close enough to the question I was fishing for me to get into this. And that is that the role of government and how you regulate and what is good regulation and what is less than good regulation. I think at the moment we are plagued with what I call the technology du jour syndrome. And it comes from policymakers, A, living on looking for shorter term rather than longer term solutions, and B, having a desire to demonstrate that they're being responsive. And so as a result, we end up with regulations that are not performance-based, but essentially are design-based. If you take a look at the California ZEV regulation, which has done, incidentally, a very good job of reducing emissions, the state of California has done an extraordinary job in reducing emissions from motor vehicles. When they started with their ZEV regulation, they were promoting battery only. The next generation then went to hybrids. The next generation incentivized fuel cells. The next generation, the one that they just came out with, are now plug-in hybrids. And all along we have this overview of ethanol being promoted. And the problem is that sometimes technology does not evolve at the pace that everybody would like it to evolve. And so the original ZEV mandate, which promoted battery, required every company to go out and build X number of battery-only vehicles. You know, it did move the state of the technology forward, but it came nowhere near meeting its objective. And I think this is the risk when there is no consistency in government policy. I spoke earlier about our fear that we're going to put these hybrid vehicles out there, and governments are pulling the rug out of hydrogen. Well, what's that do to a company like ours that's invested billions of dollars in fuel cells, and we're trying to get them to the market, and now the infrastructure that we were promised wasn't going to be there? I would much rather see governments say, this is the goal by which you need to do it, use whatever technology you think is appropriate, go forth and prosper. But if we keep having this process of running from one technology to another based upon what very slick salesman says is going to be the technology of the future, it's going to slow us up, and it's going to result in massive inefficiencies. And I don't want to get into the ethanol debate here, but I'll just mention that word.
I think in principle I agree that give the goals and the entrepreneurs will find the best way to reach that goal. Sometimes it helps at least if the governments give directions or subsidies. I used to be in the solar business, and we had a great time building up an $8 billion company because the German had a solar plan where they emphasized solar compared to other energies, even if it was maybe not economic at that time. So sometimes some direction help. There are extremes. I was invited by the Central Committee of the Communist Party of China last summer, to my big surprise, and they told me that we have decided we will have electric cars in China, and we have instructed so and so many provinces to build factories. That's the way to do it. I don't think that's the American way to do it. I think the entrepreneurship thinking from MIT will find better ways.
Thank you. We'll go over there, please. Yes. That's
Hi, Alex Johnson at Harvard. This question is mainly for Jan, but the others may want to comment. You talked about partnerships with electric utilities. I wonder if you would have considered partnerships with, say, car sharing or rental services to help people get over the barrier of having a car that's too small for every purpose.
Absolutely. I say one part of our plan is actually each city, we are city-oriented. Each city we go into, we work with the mayor, find out what are the objectives, how can we integrate the electric car into the public transport ideas, and very logically comes up the idea, what do we do with car sharing? We even coined a concept we called Think About. We have Think About Oslo, Think About Copenhagen, Think About Monaco, which is car sharing initiatives. So that's absolutely the way to get the total transport initiative much easier, much more CO2 efficient. We've been working a little bit with the Clinton Climate Initiative on those ideas also. So you're absolutely right.
Try somebody in the middle to move around a bit. There you go, sir. Yes. With your hand up. You just turned your head. If you stand up, that'd be great. Okay?
Leave my lucky never come up. Look, one of the problems of dealing with the problem of this scale, okay, is not sort of the additions that we're putting into the fleet, but the scale of the thing that you're trying to add to. So does anyone have any creative ideas about the subtraction element? I mean, what do you do about all these existing technology vehicles that are out there? How do you speed up their retirement?
Well, let me say something about that, because it turns out my group here at MIT has been working actively developing fleet models that let us follow how new technologies and changes in technology can come out into the in-use fleet and have an impact. And the in-use vehicle fleet out there behaves in a well-known way. You know, old cars get scrapped, new cars get added, middle-aged cars get crashed and sometimes die. But so that's the way it works, and all those numbers are quite well defined. And so we can track what happens to new technologies. Your question's a good one, because often that's a piece of having impact that is left out. Obviously, you've got to develop these technologies to the point where they're marketable, they appeal, and then you've got to build up production. And we had some comments about how hybrid production right now is there, yes, but modest levels, a couple of percent, and it's got to build up. But then you've got to have high volume production for a few years before you've got lots of vehicles out there with better technology having impact. So I think it's something to be very aware of. things can't change tomorrow. It does take time. And lifetimes of cars run around 15 years.
Getting longer.
So, and they're getting longer. So it takes a good chunk of a lifetime before you change the fleet with high volume production. Anybody want to add?
I think it's a very interesting philosophical question, and I know I had that discussion with the German automakers. They want to make quality cars. Volvo wants to make a car that lasts 18 years. Is that environmentally good? Or should it only last 10 years? Because in 10 years you have a much better technology. It's an interesting and difficult question.
I will note that we've experimented with clean air strategies. Various states have experimented with scrappage programs, trying to provide incentives from lawnmowers to vehicles to get people to scrap their vehicle and buy a new, cleaner vehicle, and they failed.
Yes, please. You're doing fine.
I came from the tire industry about 6 years. I mean, one way to look at an engine, which is Dr. Haywood, this is what you do, and this is what I do. I'm visiting professor here. I think you raised a good question, which is how much we can save in a certain period of time, right? For example, rolling resistance of the tire, right? You can get saving there about 10%, right? And this is the 10% you're looking at from the engine side, right? And I wonder, like, how much emphasis, like, as you are in Honda, from the vehicle or manufacturer on the tire industry, because that tire industry by himself working, without consulting that much with the vehicle industry.
There's no question lower rolling resistance tires is a component of what will have to happen. It's almost a no-brainer. I'm not sure about the extent to which there's collaboration between the tire industry and the auto industry, but each auto manufacturer has its suppliers, and I'm not sure what you've described is the case in our company.
One of the things EPA's noticed is that there's often substantial differences between the rolling resistance of tires on new vehicles, so they perform really well on the EPA test, and then with the aftermarket tires that consumers replace the original equipment with, and there's often a substantial degradation of performance.
Yeah, I have this vague recollection that in the energy bill there are a couple provisions on that in terms of, I don't recall whether they're consumer information provisions or what they are, but...
It's tire labeling, yeah, to give consumers more information.
But it's a very good question because tires have a lifetime that's a few years, 2 or 3 years. Right. So that technology can get changed much more rapidly than the total vehicle technology, and there are some opportunities, but there are some trade-offs, all right? The kind of tires that give you low friction and better fuel consumption by useful but moderate amounts, they ride harder. And so, you start to get into some of the trade-offs that are involved in the vehicle design and market requirements. So it's complicated. We've got time for just a few more questions. Sir, yes.
Professor Haywood, this is partly addressed to you. Listening to the panel, I've been trying to do some back-of-the-envelope calculations, and I see this 40% saving coming along. It probably won't, well, I know it won't come by 2020, because we've got to take the whole fleet. So I'm assuming it'll take till 8 years after 2020. I'm going to give it 20 years for this to happen. Now, in that period, the vehicle fleet, miles driven, I think we had was growing by 2% a year. So miles driven is going to have gone up by 40%. So we're going to be consuming exactly the same amount of oil then as we are now. My question to you is, do you think, with your technical background, that we're being demanding enough?
The last phrase you said was?
Are we being demanding enough? Should Christopher and the EPA be really trying to do something significant rather than just keep us flat?
That's the inconvenient truth.
That's the inconvenient. Well, in our fleet modeling, we often project 2030, even if we're brave, further ahead than that. And as you said, 2% a year, 20, 30, 40 years, it doesn't make sense. And so many of these things that are growing, like miles driven per car per year, they're going to have to level off because congestion and other factors, higher cost of driving will do that. So these are uncertainties that we need to understand better. There's no doubt about it. But your basic point that growth is something we have to be honest about, face up to, and recognize that that is a population growth and then a behavioral issue. And if we don't start taking that seriously, we're obviously going to lose a lot of what the technology is going to do for us.
At the high risk of disagreeing with Professor Hayward, we have had for years arguments with our colleagues at the Energy Information Agency over VMT projections, growth projections, and they would always argue, just like I just heard the professor say, well, eventually this is going to level off, old people are going to drive less, congestion, and this is going to take care of itself. And every year, they've been wrong in terms of this vehicle miles traveled, and it has to do with wealth and culture. And I mean, where I live, not in my family, but everyone, as soon as they turn 16, they expect that their parents are going to buy them a car, and they drive themselves to school. I make my kids take the bus. But the growth is part of this reality, and you expose the inconvenient truth. And I was a little bit nuanced in my close there in terms of, are we going to choose every 5-year incremental, what are the product plans, what's in the market approach to solving this problem, or can we somehow come up with an integrated, comprehensive, all parts of society working together to come up with something that, again, using John Doerr's words, is more disruptive, because this 3% per year is not going to get us to 450 parts per million.
We'll have one more. You, sir, you've been patiently persistent.
You did not mention the difference in mileage that you get with the electric car versus a comparable, the same car using a gasoline engine, for example. And I know there's a company here in the United States that's called Vectrix that has developed an electric scooter. Interestingly enough, it has less than 300 moving parts versus a normal scooter that has between 3,000 and 4,000. And they get, I believe, comparable 500 to 600 miles to the gallon. So I think this could be a little bit disruptive, which you are mentioning, if you really get that level of increased mileage per using the electric motor versus a gasoline motor.
Yeah,
so
and I think that the development on the battery side, not only at MIT but also in European universities, actually is very, very promising. So we'll get better and lighter batteries, which means lighter cars, which you can go further. Absolutely. There's one simple solution for the whole thing, which won't work. At least we are strongly opposed to it as ever. It's just to reduce speed. We have in Norway, the government every winter reduces the top speed by 15 kilometers. We're very irritated, but they have an argument. We use much less energy by going 50 miles maximum instead of 65 miles per hour. The Germans don't like it, obviously.
Won't go over so big here either.
No.
Not in Montana.
Well, thank you very much, panel. Let me just say a couple of words. We'll give them a round of applause in just a minute. Let me just say a couple of words. I think we've, as an audience and panel, we've done well, because I think we've been well grounded. And my sense is we're getting better at that. But if we're not well grounded, we won't really know what our challenges are and what the real opportunities are for making a difference on those sort of challenges and issues. So I think that's been very healthy. And what I'd also like to say is that I think we haven't focused on just this or just that. We've spread our comments and questions around. And let me give you, MIT is a quantitative place, so let me give you a little quantitative illustration to take away. Suppose we can find half a dozen areas. Maybe I drive less aggressively and obey the speed limits. That's one. I buy a hybrid. I do a series of things, all in different areas, and they compound. If you multiply 0.8, which is 20% better, if you multiply 0.8 by itself 6 times, you get a quarter. Now you say, well, maybe I can find 6 areas where I get a 20% improvement and they're compound. I get a quarter. But then one of you was talking about growth, and we were. Suppose you lose half of that through growth, now you got a factor of 2. Well, that's not bad, but it ain't anywhere near good enough. So what that really says is everyone, and in every area that has impact, we've really got to explore, can we do this, and can we realize that impact? And so I think that's the message that I'd like to leave with you, and I think the panel has reinforced that well. And also, I think we've done well. We've used the pronouns I and we, and we haven't used the they and them. And that's very healthy, because this is us. As consumers, maybe we work for a manufacturer, maybe we work at a think tank, maybe we work for the government, but it's us. So I'd like to thank our panel. I think we've done very well and appreciate your interest.